Hi, today we are learning about modulus and argument of a complex number. So if suppose there is a point P, okay, so there's a point P and this is OP, which is representing complex number Z, and where Z is x plus iy. No need to say that on x-axis it is a real part and here it is imaginary part, and this is called angle theta. Okay, and it is always measured in anti-clockwise. So remember, theta angle always measured anti-clockwise. This is really important point you need to remember here. So z is x plus iy. So if we, this is y part and this is x part, so let's write down here this is x and this is y. So if we remember SOHCAHTOA, so tan is opposite over adjacent, so this is opposite and adjacent. So like tan theta is y over x. If we find out theta, so theta will be tan inverse y over x. Okay, and this theta is known as argument z. Okay, this theta is known as argument z. So argument z is basically an angle made with x-axis here, or you can say argument z is an angle made with x-axis by this complex number z. So here you can say argument z, which is equal to theta, and theta is equal to tan inverse y over x. Okay, so this is argument z. Let's see example. Suppose here I have made two x's. So suppose this is our first case. Here is angle. Yeah. Suppose here angle is alpha. If you want, you can take theta. It's up to you. Alpha, and this is first quadrant. Yeah, first quadrant, and this is z, complex number, which is equal to x plus y. So here, if you are measuring in anti-clockwise, then you can say argument z is equal to alpha. Okay, now if and this z is in the second quadrant, like here, if it is in the second quadrant, so like here, so this is z is here. So in this case, what will be, so here angle made with x-axis is alpha. So in this case, argument z will be measured in anti-clockwise pi minus alpha. So remember, this alpha is the acute angle made with x-axis. Here alpha is the acute angle made with x-axis, and we are measuring anti-clockwise, so here it is alpha. Here we are measuring anti-clockwise, so argument z is pi minus alpha. Okay, now let's see another example. So what about alpha here? So I can write down alpha is acute angle made with positive, this is short form positive x-axis. Okay, so alpha is the acute angle made with the positive x-axis. Suppose angle is in third quadrant. So third quadrant, so let's here. So angle made with the x-axis is like this, alpha. Measured it anti-clockwise. So in this case, because it is in negative direction, so here what will be the argument z? Okay, and if it is here, what will be the argument z here? Any idea? Any guesses? Okay, because it is in negative direction, let's show you this one. So if we are measuring anti-clockwise, so anti-clockwise is like this, but because it is in negative direction, so immediately you can write down argument z is minus alpha. Okay, here it is, argument z is minus alpha, or in this case here argument z will be minus pi minus alpha. Okay, so if z lies in the third quadrant, then it will be pi minus alpha, and then it is, if it is lying in fourth quadrant, then argument z will be minus alpha. Nice and easy. One more important thing I want to mention here, argument z, okay, it is always measured in radians. So remember here one thing, like pi radian is 180 degree and 2 pi radian is 360 degree. And one more thing you should know about it, that argument z is usually given in radians. So if we see example z equal to 12 plus 5i, okay, so 12 plus 5i, so this is our real part and this is our imaginary part, and we can draw it. 12 plus 5i, so 12 will be here and 5 will be here. So suppose this is, so this is our 12 part and this is our 5 part, right? And so this is angle theta or alpha, whatever you want, you can take it. Yeah, so this is 5 and this is 12. So here argument z will be, argument z is basically an angle made with the complex number z with x-axis, that is theta, and theta is tan inverse y over x, just I have explained you. Okay, so it will be tan inverse, y is 5 over 12. So tan inverse 5 over 12, if you put in a calculator, it comes 0.39. So argument z is 0.39. Let's see another example. So here z equal to 2 minus 2i. So again here it is real part and this is imaginary parts. So 2 is positive, so we are going 2 steps this side, and minus 2 will be negative. Yeah, so minus 2 will be negative, so let's join them. Okay, so this is our vector 2 minus 2i. So angle made with the x-axis, that is theta. So here tan theta will be y over x. So y is, this is basically 2 and this is 2, so 2 over 2. So here theta is tan inverse 2 over 2. 2 over 2, that is 45 degree, but we are measuring in radian, so we can write down pi over 4. Now if you see, we have seen that if angle is here, then we write down, I can show you. If angle is here, so then what will be the argument z here? So if you see angle is here, then argument z is written minus alpha. Okay, so we need to put minus sign here. So let's drag it down. Yeah, so 2 minus 2i. So here argument z we can write down, argument z we can write down minus pi over 4. Yeah, is that clear? And what will be the, if they are asking about the modulus, so modulus is basically if z is a complex number given by x plus iy, then modulus of z is given by x square plus y square. So in this case, what is x? X is 2, 2 square, 2 square, and y is also minus 2 square. Okay, so 2 square is 4 plus 4, that is root 8, and root 8 you can write down 2 root 2. So modulus is 2 root 2 and argument z is pi over 4. Let's go for another example. So this is our another example, minus 8 minus 15. So this is our real part, this is our imaginary part. Minus 18 will be this side and minus 15 will be down. Yeah, so suppose this one. So angle made with x-axis, which angle? Acute angle, so it is theta. So here we can write down tan theta, this is basically 15 and this is 8. So tan theta equal to 15 over 8. So theta will be tan inverse 15 over 8. If we put it in a calculator, tan inverse 15 over 8, it will be 1.080. Now what will be the argument z here? So if it is here, then argument z is minus alpha. If alpha is here, then argument z will be pi minus alpha, minus pi minus alpha. So in this case, argument z will be minus pi minus alpha. Alpha is 1.080. So answer will be minus 2.06 in radian. Okay, nice and easy. So I hope you have understood about the argument z and how to calculate the modulus. And if you want to calculate the modulus, its modulus of z will be 18 square plus 15 square. Yeah, so 18 square plus 15 square, we can do it easily. Yeah, so this will be 18 square plus 15 square. Yeah, okay, so we can solve it. uh, I just want to correct one thing here. I have written here 15 and 8 here, but by mistake I have taken 18. So let's minus here. So it is 8, 15 over 8. So 10 inverse 15 over 8 is 1.080. That is minus pi minus 1.080 minus 2.08. So it should be 18 square. Instead of 18, it should be 8 square. So 8 square is 64. 15 square is 225. If you add them, then it becomes 189, and 189 is 17. Square root of 189 is 17. So I apologize for that. By mistake I have written here minus 18. It has to be 8. Yeah, so I hope you have enjoyed this video, and if you haven't subscribed my channel, please subscribe, and thanks for watching. Goodbye.